The Linux terminal is one of the most powerful and essential tools in cybersecurity and DevSecOps practice. Unlike graphical interfaces, the terminal gives you direct, precise, and scriptable control over a system. Understanding how it works, what it is built on, and how to use it effectively is a foundational skill that every security professional must master before moving on to advanced exploitation, system hardening, or automated deployment pipelines. What is the Linux terminal? The terminal, also called the command line interface or console, is a text-based interface that allows a user to communicate directly with the operating system by typing commands. When you open a terminal, you are interacting with a program called a shell. The shell reads your input, interprets it, and instructs the operating system kernel to perform the requested actions. The most widely used shell in Linux environments is called Bash, which stands for Born Again Shell. Other shells exist, such as ZSH, Z-Shell, Fish, and Dash, but Bash remains the standard in most server and security contexts. It is important to distinguish between the terminal, the window or interface where you type, and the shell, the program that processes your commands. In practice, both terms are often used interchangeably, but understanding the distinction helps when configuring environments or troubleshooting access issues. The Linux file system structure. Linux organizes all files and directories in a single hierarchical tree, starting from the root, represented by a // There are no drive letters like in Windows. Every file, device, and process is represented as a file somewhere in this tree. Key directories you will encounter constantly in security work include /etc. contains system-wide configuration files. For example, /etc/password lists user accounts, and /etc/shadow stores hashed passwords. These are critical targets during privilege escalation and auditing. /var contains variable data such as logs. /var/log is where system and application logs are stored, essential for forensic analysis. /tmp, a temporary directory where any user can write files, often exploited during attacks to stage payloads. /home contains personal directories for each user account, for example, /home/Alice. /root, the home directory of the superuser, root, not to be confused with the root of the file system. /bin and /user/bin contain essential user-facing executable programs such as ls, cp, or bash. /spin and /user/spin contain system administration executables typically reserved for the root user. /proc, a virtual directory that exposes information about running processes and the kernel. For example, /proc/1/status shows details about process number 1. /dev contains device files. Disks, terminals, and other hardware are represented here. Navigating the file system. The most basic terminal skill is moving through the file system. The command pwd, print working directory, tells you where you currently are. The command ls lists files and directories. Adding options changes its behavior. lsl shows a detailed list with permissions, ownership, and file size. lsa shows hidden files, those whose names begin with a dot, like bashrec. Combining options is possible. lslog gives both. The command cd, change directory, moves you to another location. cd/etc takes you directly to the /etc directory. cd goes one level up in the hierarchy. cd tilde or simply cd takes you back to your home directory. Understanding absolute paths versus relative paths is critical. An absolute path starts from the root, /home/alice/documents/report.txt. A relative path starts from your current location. If you are already in /home/alice, then documents/report.txt refers to the same file. File and directory manipulation. Creating files and directories is done with touch, creates an empty file, and mkdir creates a directory. For example, touchnotes.txt creates an empty file called notes.txt. mkdir projects creates a directory called projects. Copying files uses cp. Moving or renaming uses mv. Deleting uses rm. Be very careful with rmrf, which recursively deletes a directory and all its contents without asking for confirmation. This command has caused catastrophic data loss when used incorrectly, including in production environments. Viewing file contents can be done with several commands. Cat displays the entire file at once. Less allows you to scroll through a file page by page, which is better for large files like logs. Head displays the first 10 lines by default. Tail displays the last 10 lines. Tailf follows a file in real time as new content is added, which is extremely useful for monitoring log files during a security incident. Users, permissions, and ownership. Linux is a multi-user operating system and enforces strict access control through a permission system. Every file and directory has an owner, a user, and a group. Permissions are defined for 3 categories: the owner, the group, and all other users. Each category can have read, R, write, W, and execute, X, permissions. When you run LSL, you see output like RWXRXR1 Alice Developers 4096 January 10, 9 o'clock script.sh. Breaking this down, the first character indicates the file type, dash for a regular file, D for directory, L for symbolic link. The next 9 characters are the permissions in 3 groups of 3. RWX, owner can read, write, execute, RX, group can read and execute but not write, R, others can only read. Changing permissions is done with chmod. You can use symbolic notation. Chmod u plus x script.sh adds execute permission for the owner. Or you can use numeric notation. Chmod 755 script.sh sets RWXRXRX. The number 7 means read, 4, plus write, 2, plus execute, 1, equals 7. The number 5 means read, 4, plus execute, 1, equals 5. Changing ownership is done with chown. Chown Bob developers script.sh makes Bob the owner and developers the group. The root user bypasses all permission checks and has unrestricted access to the entire system. In security contexts, identifying which commands can be run as root by a regular user is a key step in privilege escalation testing. The command sudo allows permitted users to run specific commands as root. The file /etc/sudoers defines these permissions. Processes and system monitoring. Every running program on a Linux system is called a process and has a unique numeric identifier called a process identifier, PID. The command PSO lists all running processes with their PID, user, resource usage, and command name. The command top provides a real-time, updating view of processes sorted by resource usage. A more user-friendly alternative is top. Killing a process is done with kill followed by its PID, kill 1234. To forcibly terminate a process that ignores normal signals, use kill -9 1234, which sends the SIG-kill signal that cannot be caught or ignored. Background and foreground job management is also essential. Running a command followed by an ampersand, and, starts it in the background, /scan.py and. Bringing it back to the foreground uses FG. Listing background jobs uses jobs. Input, output, and redirection. Linux commands work with 3 standard data streams: standard input, keyboard by default, standard output, screen by default, and standard error, screen by default, but separate from standard output. Redirection allows you to change where these streams go. The greater than symbol, greater than redirects standard output to a file. LSL greater than output.txt saves the listing into a file, using appends to an existing file instead of overwriting it. The less than symbol, less than feeds a file as input to a command. The pipe symbol, vertical bar, connects commands together, feeding the output of one as the input of the next. This is one of the most powerful features of the Linux command line. For example, cat/var/log/auth.log, grep failed, tail -20 reads the authentication log, filters only lines containing the word failed, and shows the last 20 of those lines. This kind of command chaining is used constantly in security investigations and log analysis. Searching and finding information. The grep command searches for patterns inside files or output. Grep root /etc/password finds all lines in the password file containing the word root. Adding I makes the search case insensitive. Adding R makes it search recursively through directories. The find command searches the file system for files matching specific criteria. Find, name.conference type F searches the entire system for files ending in. Conference find /var/log mtime-1 finds files modified in the last 24 hours. These are essential for locating sensitive configuration files or recently modified files during a security audit. The locate command offers faster searches by using a pre-built database, but it may not reflect very recent changes unless the database has been updated with updated B. Environment variables and the path. Environment variables are named values stored in the shell that influence the behavior of programs. You can view all of them with the NEE command or view a specific one with echo $variable_name. For example, echo $home shows your home directory path. The path variable is particularly important. It is a colon-separated list of directories where the shell looks for executable programs when you type a command. If you type ls, the shell searches each directory listed in path until it finds the ls executable. You can see your path with echo $path. If a malicious binary is placed in a directory that appears before the legitimate one in path, it can be executed instead of the intended command. This is a real attack vector known as path hijacking, and understanding it is essential in both offensive and defensive security. Text processing and useful utilities. Several command line tools are indispensable for processing text data, which comes up constantly when analyzing logs, configuration files, or command output. Cut. Extracts specific columns from text. Cut D. F1/etc/password extracts only the usernames, the first field, delimited by colons. Sort. Sorts lines alphabetically or numerically. Unique. Removes duplicate consecutive lines. Often used after sort. Sort file.txt, unique C counts occurrences of each unique line. awk. A powerful text processing language. awkf. Print $1, $3/etc/password prints usernames and their numeric user IDs. A stream editor for modifying text. sed/old/new/gfile.txt replaces all occurrences of old with new in the file. wc. Counts lines, words, or characters. wclfile.txt counts the number of lines. These tools become extremely powerful when combined with pipes, enabling complex data analysis with a single line of terminal commands. Network-related terminal commands. For a cybersecurity professional, network diagnostic commands at the terminal level are used daily. IP address, or the older ifconfig, shows network interface configurations and assigned IP addresses. PenTest connectivity to a host by sending Internet Control Message Protocol echo requests. SS, or the older netstat, shows active network connections and listening ports. SS-TOLIMP shows all listening transmission control protocol and user datagram protocol ports with the associated process. curl and WeJ are used to transfer data over HTTP or other protocols from the command line. These are frequently used to test web endpoints during penetration testing. SSH, Secure Shell, allows encrypted remote login to another machine. SSH Alice at 192.168.1.10 connects as Alice to the machine at that address. Why the terminal matters in security. The terminal is not just a convenience in cybersecurity work, it is a necessity. Most servers, especially in production environments, run Linux without any graphical interface. Penetration testing tools like Nmap, Metasploit, Wireshark, in command line mode as Shark, and scripting with Python are all operated from the terminal. Log analysis, user auditing, network monitoring, and secure configuration all require confident command line proficiency. Moreover, when you gain access to a compromised system during a penetration test, you will almost always have only a terminal, often a limited shell. Knowing how to navigate, search, escalate privileges, and extract information efficiently in that environment is the difference between a successful and failed engagement. Building strong terminal habits from the beginning, understanding paths, permissions, process control, redirection, and text processing, forms the foundation upon which all advanced Linux security skills are built.